What's up? There's a question from 2022. I need to fix it or give you guys points if I can't fix it. I can go in administratively and look at it. I saw like a text. I think that was you. I think all three of you texted me in the back row. So I'm not sure who texted me up, but yeah, that wouldn't happen because it's a post test and it's based on your highest attempt. So I could go and fix it. You could get a worse score and your higher score would count. It's just on the exam, it's only 2 attempts, but it's unlimited on the pre-test and post-test. So I can fix that and then it won't hurt you. If I can't fix it, I'll just give you guys a point because a point here or there is not going to do a ton to your grade if you know it or not know it, you know? So, but yeah, I can go ahead and do that. I think it's the same. I think it's jumbled. Hey. How was the Dominican? Oh, good. Oh, that's fun. Do you guys get charged for calling the firefighters too? No? Oh, because it's probably your first. I know I used to have an alarm at my house, but I know if like they show up, I think 3 times. The third time they like charge you. I think the first 1 or 2 is free, or after the third time or something. Because I remember the alarm got set off a couple times, and it was like a chipmunk or something stupid. So they were like, if we come back to your house again, we're gonna charge you. So that's cool. Doing Cancun in like a month for 17 days. So yeah, I'm going to Cancun. Looking forward to it. Yeah. Walk on the beach, like whatever. So I'm working on doing the VIP or things included. So, but I got the tickets already. So round trip, nonstop from Chicago to Cancun. Just get on the plane and get off the plane. So. Morning. Hi. Misha, you're not here. I see you, Colleen, Alexa, Gustavo, Valentin, Carlos, Nick, Jonathan, you're not here. Annie, welcome back. Katie, you want it? Perfect. What was that? I can do the attendance in a moment or something, but it's not related to how you do in the course. It's just they like to see you attend X number of times or something. So, but I think we were on chapter 6, right? So I'd probably just so you have it, I would go into chapter 6 And I would click on this helpful z-score table. That should be a Word document. No, it's not what I wanted. Okay. Never mind, we'll go back to that in a moment. Okay. Cool. This stats share slideshow. I think we got all the way to 6.1. Right here. Okay, cool, perfect. All right. You guys ready? In the back. All right, so we were talking about z-scores. Z is equal to x, or the value, minus the mean divided by the standard deviation. So that's, we're saying here, we were given a score of 14. So z is equal to x minus m over the standard deviation. So in this case, it's our value was 14. 14 minus 12 divided by 2 is our standard deviation, is equal to 1. We're normalizing the value to get the standard deviation from the new value. So there's practical applications because you can see if something's effective, which we'll walk through, where there's some sort of intervention and the X value changes, does the intervention work? So there's absolutely a way you can use it in real life. You should all have a probability distribution table towards your appendix. Does everyone know where that is, or can you locate that if you haven't already? In your book, you have a Z table. It should look kind of like this. We're going to refer to it. Welcome, I'll mark you here while everybody's grabbing that ledger. So it'll say like Z table, unit normal table. I believe it's appendix C. It might be B or D or something based on electronic or paper. So we're gonna have just still loading. Okay. Yeah, I'll redo attendance here so that we count you here, Anisha. Here we go. We're not gonna do anything with it yet. I would just make sure you're able to locate your appendix C Z table. Because that part 3 that we didn't do yet, we're going to be referring to it to get there. It's fine. I can wait a moment for it to load. No big deal. So as you can see while you're loading that, we'll have like what our Z-score is, your area between the mean. So like right here and here is your column B, your mean between the area between here and the Z-score. And then the area beyond Z in the tail is like where the curve dips down. So this space right here is the area beyond the Z. This is the area between the mean and the Z. And this of course is like a Z-score by itself. We'll use that because we'll do some calculations where we'll say, hey, does this thing exceed? We'll figure out critical value, and then we'll look at if we're at or beyond the critical value if something happens in terms of situationally under scope of research. Everybody have a Z table, or at least know where it is at this point? Okay. So column A that we just looked at, those are only your Z scores. A negative Z score is equivalent in the symmetrical distribution. Does that make sense? Because it's to the left or the right of the mean, or basically the 0. Mean is Z is equal to 0. Z is equal to 4 distance from the mean, or 4 standard deviations. We're basically converting a Z score, basically takes and makes it equivalent to a standard deviation. Column B, area between the Z score and the mean. Same thing, as Z score increases, you move away from that mean. And then the proportion of the area between the mean and the z-score increases closer to half because we're taking that symmetrically and we're dividing it. As the score increases, the score decreases closer to 0 or closer towards the tail. So everyone have a sense of what I'm talking about with the curve. Middle is like your mean, kind of like right at the average at the top. These right here are like your tails, and like we approach basically 0 as we go further along the tail. Obviously, this all equals 100% or 1, 0 to 1. If we had nothing varying, we'd have a straight line. So everyone have this so far. We're going to do a practical application on part 3 of that worksheet and some other stuff. So we will get a chance to work with this. So it's given as a proportion. That's your unit normal table. So we use the z-score to locate the probability for the score. So we're going to transport the z-score into a raw score. What does that mean? Just this formula. Locate the corresponding z-score in the unit normal table. We're literally going to practice that. So if that doesn't make sense, don't worry about it yet. But basically, what we're going to do is we're going to have columns A, B, and C, and then we're going to reference one of them, and then go towards our z-score, figure out what that z-score is, and then we're going to use that to check if something is or is not happening in these scenarios, just through math. Then, of course, you can sketch it to understand negative and positive areas, because obviously this is more of like your negative, that's your positive area with z being 0 or the mean. Does that all make sense so far to everybody? Conceptually, don't worry about the math yet. We're going to do the math today. So we got that. Oh, yeah, no problem. Everybody else needs that. So whenever you see this, so this is data showing if we're chewing gum, if it's improving academic performance. Not very scientific, but hey, maybe, right? On a standardized math test, 20 plus or minus 9 points. Whenever you see something like 20 plus or minus 9 points, that is your cue, because you'll see it on tests, mean plus or minus standard deviation. That's how they're always going to list it. So we're saying the math test, the average was 20 points plus or minus 9 points in terms of the variance of the standard deviation, the square root of that variance. Assuming the data is normally distributed, that just means bell curve. What probability that the student who chews gum will score 11 points the first time and 29 points the second time? So now we're dealing with probability based on the z-score. Is chewing gum actually going to be helpful? We're going to have this so far. In a few moments, that's fine. So we can find that out because first we take our first value, 11, and we're going to plug it into the formula. 11 minus 20 divided by 9, our standard deviation, is equal to -1. I'm just going to write that down somewhere. We're not going to do anything with it yet, but we will. Once you know that, you find the z-score of 1, because it doesn't matter. It's considered all z-scores positive, because the only reason this is -1 is to the left of the 0 for the mean. So you find in your z-score, find look for proportions between 1 and the mean, and your p-score should equal 3.413. Does everyone see that in your z-table? Hopefully. We're going to practice, but you should be able to find that in those columns A, B, and C. So to find the proportion between the two scores, we're going to add 0.3413 to the proportion associated with the second score. We're going to practice this too. This is just setting that up with the example. We have some other examples in a worksheet coming up today. Yeah, you add the two values and you get the probability. Yeah. And this is because we're dealing with two different scores versus just like under or just over. It's a little bit different, but for this one, yeah, you add the two together. So we're gonna have that so far. Totally keep that up there for a few moments. So that's our next step. I can go back a slide if I need to. So we're gonna take 29 minus 20 divided by 9. We get 1. It's the happens to be the same proportion, same z-score. So we're gonna go find that again in our z table, and we're gonna add the probability of 0.3413 plus 0.3413 to get 68.26. If we multiply it by 100, we'd have 68.26%. We're gonna practice this. So writing it down, it's clicking, wonderful. If it's not, we're gonna do like, I think 4 or 5 problems approximately, walking through this a bit. So, and I think have you create some of your own too, which I'll come around. So it should stick today if it's not quite making sense. So everyone have this so far. Some people are still write stuff down. Absolutely fine. So if we want to see if something falls within a specific proportion, we can use the z-score associated with a given proportion and work backwards to figure out the x score. So basically just working backwards if you had algebra, basically just solving for a different variable. So we could transform the z-score into the raw score x. Step 3 is z times the standard deviation plus the mean to see like where it falls. We're going to primarily, and this all you're looking at with step 3 is moving this around basically to solve for another variable for the value. When you're ready, I'll give you another example here on the slides before we jump into the worksheets. Tell me. So in the general healthy population, IQ scores are normally distributed. 100's average, your standard deviations. So it's usually about 15, like I was telling you before. So again, this is mean right here. That's going to be your mean plus or minus your standard deviation. So remember, will that be your Q? Assuming the data are normally distributed, normal distribution, what minimum score is needed to be in the top 10% of the distribution of intelligence scores in this distribution? So we're saying what would put you in that top 10% based on what's already happening with the intelligence scores. So we're going to look up the Z in the Z table. So Z should equal 1.28 in your table. So step one, everybody's following along with me. 10% of the score is the same as P equals 0.100. Now, as everyone know, we're getting P equals 0.100. We're moving it over 2 decimal places. So the 10%, remember, we always go multiply it by 100, or you could divide by 100. Moving over 2 places, so its probability is equal to 0.10. So we're going to look for that in column C, in appendix B or C. In your z-score, you'll find as you move your eyes over to the left is 1.28 if you're checking this against your z-table. So that means the cutoff, when I say cutoff, what does it, I mean the cutoff, like this is where those scores are going to be. And by the way, if it's at it or beyond is what we're looking for. If it's inside, that's different. That'll make sense a little bit later on. So we're trying to see what happens. So we determine which score X in the distribution corresponds to the z-score value. Z is equal to 1.28. You can just substitute the value, the z-score times standard deviation plus the mean. So 1.28, because we got the z-score, is equal to X minus 100 over 15. 100 is your mean. X is your value. So you can do that. You can do that either way. So we're just plugging that in. So basically, we're working backwards to figure out what X is. So it looks like this. Go back if you need me to. Just talk to me, everybody. Trying to keep an eye on how you're writing. Z times standard deviation plus 15 equals 1.28. 15 plus 100 is 9.2. So we're going to multiply by 15 to get that, to basically eliminate that. Then we're going to have 19.2 is equal to X minus 100. So we're going to add 100 to each side. So X is equal to 119.2. So therefore, a score equal to 119.2 is that's the cutoff right here for the lowest score in the top 10% of the scores by working backwards. So 119.2 or higher, normal distribution, cut off that top 10%. You could use this in the real world if you were trying to look at the top 10% of people, like in sales or performance metrics or something. There is a practical application of looking at this information. If you're wondering, I see a lot of stuff, or at least the first week or so, like how can we use stats in the real world? You absolutely can use stats in the real world. This, I believe there were some questions on this. I think I got an email or two, or someone raised their hand last class. From binomial to normal, distribution of random outcomes. So when you get these, you're going to get 1 or 2 or 3 of those variables, and you plug it into the formula. N, of course, still your sample size. P and Q are your probabilities for the binomial outcome. I'm going to walk you through what those typically look like, P and Q, in just a moment. Yeah. For a binomial outcome. So you can use either formula depending on what information you get. Remember that fancy U is like our mean, and it's capital mean for the sample. The fancy U is the Greek mu for a population. Is everybody to that point? So binomial distribution approximates normal distribution as long as n is greater than or equal to 2. The larger the n, if it's at least 2 or higher, the more it's going to provide us an approximation of the normal distribution. When n is affinity, the binomial distribution, theoretical perfect distribution. Oh, yeah, absolutely. So that can be used to estimate binomial probabilities when n and p or n and q are greater than 10. Where we have some practice coming up. If n, q, and p aren't making sense yet, they absolutely will soon. Example in a moment. If you're still writing, totally fine. So suppose you select 2 participants from the population, equal number of men and women, random variable X number of men, sample of 2 participants, 3 possible outcomes, 0, 1, 2. So we have 2 people in the sample, 3 possible outcomes. So assuming n and p and q are greater than 10, binomial probabilities can be approximated using standard normal distribution. Check for normality. Normality is that bell curve. Is it normally distributed? Compute the mean and the standard deviation. Found the real limits. Remember, the real limits are plus or minus 0.5 at the top or bottom of your range. So x and x plus or minus 0.5. Locate the z-score for each real limit, and then find the proportion located within the real limits. We're going to practice with the z-scores. Some of you are going, oh, this totally makes sense. Some of you are, as you're glazing over a little bit, that's okay. We're going to work through it, all right? So graphically is our probability, because that's that between the, that's 0.414, real limits 29.5 and 30.5. This is right above and below that 30 that were sampled. That's where that's coming from. And we're going to practice z-scores in a second here. So far. Okay, so the next thing we'll do is let's pull up that worksheet from last time and just look up z-scores on those last 5 for part 3. I believe that would be the 627 worksheet that we skipped. Just look up some z-scores, take a few minutes and do that as an individual, partners, group. We'll look at those. We'll go over the answers with you guys that you found this correctly, and then we'll do a little bit more in depth with z-scores and what this all means and how to calculate it so you can practice with the math. So what we're talking about is You go student resources right here. For you weren't here or you missed class. I do the recording. I'll get it posted probably today and Mondays. And should be right here, part B. And then you would have clicked on this from Monday. And we did these and you came up with your own probabilities. Column A. So there's 3 columns. Here are our z-scores. Look at each one in the unit normal table, write down the values C in columns B and C across from it. So you're going to have a comma, 2 values, comma, 2 values, and so on. And then we'll go over it because I can pull up the Z table here for you all in terms of the answers you got. So take a few minutes, do that. If the Z table is not making sense to you or the values or the directions aren't, raise your hand, ask questions, I'll come over, and then we'll go over it. They should go pretty fast, but so you're just finding the columns to the left and right. I'll show you. So you should have your appendix, you should have a Z table. I'll show you what it looks like in just a second. I'm just uploading it right now. Just a second to build content, file. Z-score table, open, submit. If you click on student resources and you click on chapter 6, now this is still in your textbook, but if you scroll down here to the Z table that I just posted, I can move this up actually. Maybe below chapter 6, you click on this, you'll get a download of Appendix C. This is what I'm talking about if you're wondering, Jonathan. These scores right here, columns A, B, and C. So you're looking up the Z score that it's giving you, and then you're going to the left, to the right area between mean and Z and the area beyond the tail, and you're just listing the 2 values for the Z score that you're looking up. Should be in your appendix, but I did post this as a PDF file as Z table under chapter 6. So all we're doing is we're just writing down the values for the 5 of those in the B and C columns. This is just to get your feet wet with what is feel basically familiar with a Z table and where to look things up. That's it. And then we're going to jump into like more detail and some problems on how to actually work through Z tables. Do you find that okay? Does that make sense now? Okay. So Lisa, your appendix is working with that one. And then you can submit the worksheet. And basically, as long as your B and C line up with the Z-score that it's giving you, you're gonna have the right answers. And if you'd like, we can talk about the answers before you submit it. If anyone's concerned they're not doing that right, but you're literally just looking at the Z-score and you're listing the B and the C, the area between the mean and the Z right here. So you're listing this area and the area beyond Z and the tail. And you're just listing those in the, yeah. Yeah, wherever you find it in the A, because it's like there's Z scores B, C, and there's more Z scores B and C. It's just for like space. It would be this one and then that one. I can zoom if it'll let me zoom in. So for the first one, it'd be 0, 0.0, and 0.5000. Those are the scores. So -1, look it up as if it was positive. So that one we'd have to go and find 1, which is, I think, up here, probably. No, not yet. Where's 1? So there's 1 right here for number 2. So it'd be 1.3413.1587 for this one. So we looked up as it was positive, so we found it right here. Z-score, that's our first column. Second column, mean in the Z, and then basically the tail. We're just listing the values. Point, you don't have to write the 0, you can. 0 point or just point and then whatever it is. And then like for this one, 0.99, we're gonna find 0.99 right here. And then it's these 3 values. It's just these 2 next to it. We're just looking it up and getting our feet wet. That's it. We're not doing any math. We'll do math in a moment. This is just so that you know, if I say go to your Z table, where do you look it up? How does it make sense? So our next one would be -1.65, but we want to look up like it's positive, so just 1.65. So same thing. We go find 1.65. 1.65. So that's this one right here. And then just going to list the 0.4505 and the 0.0495 to the right of it. The Z table is also in chapter 6 now. I just uploaded it. So you can use your appendix or this, whatever's easy for you. And then our last one is 1.96. So it's the same thing. We're going to go find 1.96, which is probably back here. 543, 1.76, 1.96, and then it's these, the 0.4750 and the 0.0250, the 1.96. So just find that Z-score in your table, look to and then write the numbers in the B and C column. We're going to work with these numbers in a moment. Again, this is just getting your feet wet. And then, yeah, you can have that worksheet in. And I think you all got emails, by the way. Just to reiterate, you have to physically walk down and get the Cengage code from the bookstore if for some reason you don't have it. I can extend WebAssign and let you get caught up. Just email me, text me. I'll make sure it happens if you fell behind. You can thank Gustavo for being awesome on that one. We wouldn't have known. Does everyone have their Z-scores or any questions on this worksheet? This is making sense, everybody. The last one, 1.96. So that's right here. So the z-score is like in the second column. So you'd have 0.4750 right there and 0.0250. Does that make sense, or did you find it? Okay. Everybody good on this worksheet? Any questions on just how to find z-scores or anything? So you can hand that in. I'll make that due probably tonight by midnight or tomorrow, because I know you get your test, your exam. Activities. All right, so we did that. We did that. I think we want this right here. Is this it? I'm just pulling up the next worksheet, making sure everything's working here. So we did that. So we'll just do the first half. It can. We're going to get into some of that in our worksheets in a moment. I'm just making sure that the worksheets are all making sense here before I make them available to you all. I think I want to do this one. Yeah, so we'll do that, then that. So update this. 6. So now let's do 629 available. So if you go in class assignments and then today's date, we're gonna do the first half of this next worksheet. So grab this one right here. Actually, we'll just edit. Mark for removal, submit. See, now it's nice and clean if you refresh. So we're just gonna grab that worksheet, not the Excel file at this point, and just do that first page. Don't do chapter 7 yet. Same thing, I want you to look at more z-scores for these and these based on what it's telling you. So it's gonna ask you what you see. So the first one is on column B, you see the area under the curve from a given z-score back toward the mean. Locate the z-score where the probability back toward the mean is. So we're going to locate the z-score. We know what we're doing? Looking up the z-scores for this one, and then I can certainly go over the answers in a moment. And then we'll jump into some more details on where we can actually use these scores and some of the math. So just that first page, it's got today's date on it. It's under in-class activities, student resources, in-class activities. Today's date 6/29. If you're still trying to find the worksheet, that should be right here. We'll change that. Submit. No, I just made it so you could see it. So student resources, in-class activities, because you can see, Carlos, see all this stuff right here? You can't see that yet. And then you scroll down and you click on this right here, today's date. And then just this worksheet, the top one, you'll get this. And again, we're just looking up z-scores, first page. I'm not making anything on chapter 7 due yet till we have a chance to work on chapter 7. Yeah. So you just, if you're gonna look it up in the Z table, just use the positive value. And how do you know that's the left or the right of your mean? In terms of what you're gonna be calculating under the tail, et cetera. But there's not gonna be any negative values listed in your Z table. And then as you guys finish, we'll go over the numbers for all 15 of them to see if you're identifying the information correctly in the Z table. But if you caught it, I can do that on my side. That's what we're trying to do. You're right. That's infographic. I might have already created. If you submit again, because I think what I did is I think I made most of all of those. I can double check that one, but I think I made them unlimited attempts or several attempts, so that way if that happened you wouldn't run into that. I'll look right now. I'll show you. That's in week 4, I believe, but I'll show you. So this should say, oh yeah, it's unlimited attempts. So you can just submit it over it, and I'll be able to take it. And then when you hand the PowerPoint in, is you click on just student resources, scroll down to chapter 4, and then there should be a discussion board in there. It's not graded, but it says exam 1 reviews. So you just click on this, and then you can just like add a thread, and then these are your notes of your classmates. It's open book, open note on the exam, so if you all want to use yours and your classmates' notes, it's fine. Nobody gets the same exam. So if that'll help it, yeah, it should just be something like, I believe you just go. Yeah, you can just go. If you add your Google Slides, it'd be best if you say anybody with link can view, because then I can view them and so can your colleagues, and they can just follow the link. So it should just be, I believe you just click on thread, and then create thread, and then you just put in like exam 1 review, and then if you scroll down you can browse, or if it's just Google you just put your link right there, and then just submit. And then so it's not, for your actual like submission for me to grade, that's in the actual assignment. That's just like for your classmates. So I don't know if I answered your question correctly, but in terms of like getting the grade, I want you to submit it right here. Exam 1 review, where it says you're like where the assignment is, where the infographic, that's where the points come from.
Okay, so it's in the classroom.
It is. Yeah, that's for, yeah. And then if you want to share with your colleagues, this is exam 1 review for the grade under in-class activities. And then to share with your colleagues, it's under chapter 4, and it's a discussion board, but it's not graded. It's just so you can all benefit from each other's notes.
Okay. And so then I just do assignment details.
And then there should be another submission button. If you scroll down, it should just automatically be there. It'll say okay, and then it's not giving you.
I did email it to you, but
Give me just a second. I can go into the master grades here. Just don't look at my screen. It's going to show all of you in a second, and then I can just go into your attempt. It was assignment 3 and 4 that was incorrect, right?
yeah.
Okay, that's easy. Just got to get over to assignment 3 and 4. I think I just passed it. Is that assignment? Okay, yeah, I'll tell you in just a second. Assignment. Homework. Yeah, here we go. In-class assignments 3 and 4. Okay, refresh, Annie. Try it now. I deleted your attempt for chapters 3 and 4, so it should be like you never submitted it. And you should have a submission button now. Does that work? You're good? Okay. No problem. Or you can tell me a break. Does everybody have their answers? All right. So you guys want to see what the answers are for the first set? So your first 5 we just did on that part 3, you should have these scores 0.00, 0.5000. Part 3, not the worksheet we're on. These second group of answers are on the worksheet we're on. So what we just did right before, you should have these answers. I can zoom in if you all can't see that. Cancel. So this was part 3 on your worksheet. If you looked at, this should make sense on your Z table. And then this is 1 through 5 and 1 through 5. These are the answers that you would have got for what I just said to get your feet wet. Those should be in line with your Z scores. If anything looks wonky, you probably grabbed the wrong column or something. But these are all Z scores, so that's like your A column. And then these are scores. This should be B and C columns to the right. That should be about what you have, unless you looked at something incorrectly or grab the column above or the row or something. Yeah. No, just one, because because the Z score, they're always positive. They're always positive. So it's plus or minus when we're talking about standard deviation. That's correct. Z score is positive because it's normalizing it. Right. Yeah. So this is part 3. Although we just finished up that because we had done part 1 and 2 for like chapter 5 for probability, and the worksheet we just did had 10 of these. So that's 6 through 15. So first worksheet here, second worksheet this. So that's what you have. You're able to locate Z scores, which is awesome. If it's looking nowhere near, you might want to talk to me or compare notes, etc. But it should be based on what you looked up in those columns in the Z score. Like I said, if it's way off, you probably looked at the Z score table wrong. It's just getting your feet wet, making sure you know where to find the stuff. Does anyone have any questions, or did anybody kind of go like out in left field here? You guys want to take a few minutes break? We're about an hour in, or we can, what, 10? I can give you 10, but I can't do 4 10s, so that's 40 minutes, but I can do 10 now if that would help, sure. Yeah. You want 5? Okay, 5. That's totally fine. Take a solid 5. If we need 10-minute breaks 4 times and we get through the material, it's fine. I just want to make sure we don't eat up too much of our time with breaks, but several breaks, totally fine. Because 4 of them at 5 minutes is 20. That's not a lot of time. 10 or 15-minute rest, like an hour we lose, you know. So what you guys do? I'll see you at 5. If you have questions, concerns, or if that's still not working, just talk to me and we'll make it happen for you. We're gonna so we can do 7 and then we can come back and review 6, or we can do more immersion in 6. I have it set up either way. So what I'll do is, because I taught this on Zoom, so it was different, but it'll still work in the class. I just will make the other half of the worksheet due until later, so you don't have to worry about 7. We'll immerse ourselves in 6, and then if we get to 7 today, then we'll probably do that thing next. It's so nice to be face to face. That's not scientific, but I appreciate what you're saying. No, it's a very strong belief, and I'm not saying what you're saying does not have value, because it totally does. But all the research that I've read says that your modality, which you learn, the one that's favored, you exert slightly less effort, and the one that's not favored, you still learn, you have to exert slightly more without the same amount more of effort. to do well in it. And if you've been in school the last 2 years or so and you're getting good grades, I just mean scientifically. I'm not. Hey, I prefer face to face. It's so nice to actually like see your faces. I also do online stuff. As long as it's like radio, like the radio lecture on human resources yesterday for an hour, talking to myself because no one showed up at 10 in the morning. Yeah. Yeah. Yes. Yeah, do that. I can make sure you access before you try. That's fine. Thanks for asking. I try to be as within reason, try to be as lenient and as flexible as I can. What I usually don't do is if when you wait all semester and the final grades get posted and then you tell me a sob story after grades are posted, I usually have almost no leniency unless it's like a crazy extenuating circumstance that I'll probably ask you to verify. But if you're talking to me during the semester and being a responsible adult, then I tend to be pretty amenable. You missed the meme, by the way. Should I show her the meme?
Oh, yeah.
There you go, Annie. Oh, that one's fun. Let's go. What'd you find?
Melissa McCarthy. I was watching the show with my mom last night, and it's like a workplace area. Like
Yeah.
It's kind of like the office, but like this guy's got like some dots get over and like Melissa McCarthy keeps getting mad at her one coworker and just saying profanities. It's really crazy.
I think she's hilarious.
Yeah.
I just updated that. They're all now. So for WebAssign, if you've fallen behind or you had problems accessing, I just opened up chapters 1 through 5 till July 2nd. You're welcome. So you can get in there and do that. 6 attempts. Like I said, if you had any trouble with WebAssign, just to reiterate, you have to physically go to the bookstore and they'll give you your access code. I think most of you were all on an email from Celeste. So I'll do that. And I think we're coming back from break in just a second. You guys ready to jump in some more? Need another moment to breathe? Or everybody's good? Just till you get to 6. When you get to 7, leave it alone. Don't hand it in yet. It's not due. If you hand it in early, I'll give you half the points and I'll ask you to hand it in again. But as I'm just doing chapter 6. We're not going to do chapter 7. We're going to delve into chapter 6 in more detail right now. When we get to chapter 7, we're going to do the other half. I tell this on Zoom. So sometimes we would like go through chapters and then go back and review. sometimes we would jump into the depth of each chapter first, so it can really go either way. Your colleague Katie here would like to keep going in chapter 6, not to put you on the spot. You probably all want to go on chapter 6 because we just jumped into it and it's face to face, and maybe, and I don't know how much people were doing stuff on their own on Zoom. So, so we're going to go like this. Student resources in class. Make available. Make. Can everybody see this? This week, folder B, go in here. You should have a chapter 6 review right there. We got some problems and some stuff to walk through. So everybody able to find that okay? In class activities. So student resources, in class activities, scroll down till you see today's date, folder B, click on that. You should see a chapter 6 review, download the doc file, and you should have something looking kind of like this looking at you. Everybody find that okay? Go through that again if anybody doesn't see it. So some review. A normal distribution is symmetrical or Gaussian or bell-shaped. Normal distribution. Normal, bell-shaped, because it looks like a bell. I mean, pretty straightforward, right? That's our mean. Or Gaussian. Most behavioral data, whatever we're looking at, tends to be in a bell curve. We don't get a lot of skewed curves. 50% of data fall above or below the mean. Again, that's at 50% of that data above or below the mean. That makes it the bell curve. Normal distribution, the mean can equal any value plus or minus infinity. Standard deviation is any positive value greater than 0. Remember, 0 is in the middle. That should make sense. Just to review. Proportions of the area under a normal curve are used to determine the probabilities for normally distributed data. So we look at proportions. We're looking at what's happening with the data under the curve. The tails never touch the x-axis. So if this is your y and this is your x and this is your curve, these don't actually touch the x-axis. Talking about the tails. That means I feel like I need a better marker. What else to review? The standard normal distribution is 1 of the infinite normal distribution, so it has a mean of 0 and a variance of 1. The Z transformation converts any normal distribution to a standard normal distribution. So basically, the Z score we just talked about, we're taking like a value and we're basically normalizing it to the Z score. So if we have X is equal to 17, we're going to end up getting the Z score, which is the standard deviation as we're converting it. That's what we're looking at. The standard normal distribution, or Z distribution, is a normal distribution with the mean equal to 0, equal to 1. The formula should be on page 180. This formula. There's two, depending on if you're dealing with population or sample. So example 1. A researcher measures the farthest distance of free throws that are made during basketball practice with professional basketball players. The data were normally distributed. M is equal to 10. Standard deviation is equal to 2. What is the score for X equals 16 feet? Well, because the mean is 10 and the standard deviation is 2, we're going to find the score X equals 14 by substituting these values into the Z transformation formula. Therefore, so Z is equal to 16 minus 10 divided by 2, which is 3. Does that make sense, everybody? Therefore, a score of X is 16 in the original distribution is located at Z is equal to 3.0 and a standard normal distribution of 3 standard deviations above the mean. And then the next thing I'm asking you to do is to draw what that looks like. And there's an example on page 181 of your paper textbook. Around the same spot. It'd be 6.4, the figure 6.4 in your electronic textbook. So using the data in the worksheet, you can use the model to draw that. Like on a scratch sheet of paper, take a photo, etc. And then we'll do an example on our own in a moment here. .4. I'll give you an anecdotal example. Should be example or figure. Should be under section 6.4 in the text. And then you should see like a drawing of it. But you want to use the data that I just gave you, not the data in the textbook. You want to kind of like overlay that? Unless they moved it, but it should be section 6.4. Are you guys able to find it in the back? Yeah. Okay. What? It's Cengage. It was not in the PowerPoint. This should be in the book. Right? Section 6.4. They found it. You don't find it? Well, you got a page number for us back there? No page number on the book. Oh, it is 21. Okay.
Oh, I think. Okay.
That's what I'm talking about. So what I'm saying is draw that based on the data we just talked about, like on a scratch sheet of paper. Yeah, just don't use their data, use our data. Gentlemen, did you get that over there? Right now. So the idea is like the example you're looking at, we're like overlaying with our data. So don't copy exactly, just like making sure I'm getting the data. And you found it? Okay.
Yeah, I'm just hoping I copy.
Okay. So I can come around. Yeah, so basically, so page so you're going to take that, and you're going to use it to basically hold it. Yeah, the original solution is analytic solution. So ours is 3. So we did Z is X is equal to 14. So what I'm saying is like you would do that, but that would be like plus 3 because it's based on our data, and it's free also to get a sense of what that looks like. Yeah, that's fine. Yeah. I just like a picture on the phone. No, it's 6.4. Yeah, so as you can see, we use 14, but our definition is 3, not 1. So what I'm saying, draw it like if you put the data in, your segregation is 3.
gonna be done slightly different, but the book's really good model for it. Use tape. Yeah, finish. Yeah, that's totally what I'm looking for. Yeah, that's it. Yeah, that's it. Like you use the example, but you make it based on the information. I think you're right.
Like two ways.
Yeah, do the original and the standard, and then substitute the standard deviation for 3, not 2, because like it's pretty straightforward. It's just like so you understand like what you're looking at.
I thought the Z-square is
3. It is. It's 3. I'm saying use what we did. Use this as your example. So you're right. You're 100% right. It is 3. It's not 1. So you would do 3 standard deviations instead of 1 standard deviation to represent x is equal to 14 on your two drawings. The textbook is just so like you have a sense of what you're looking at. Just alter it to be standard deviation is 3, not 1. Or because you two are drawing it correct, I can just mark it. Yeah. And I think we're using 14 and 16 is coming out. Same idea. Same idea. Did I say 16?
Yeah.
I did. You're right. I was thinking 14. Yeah, we did do 16.
Yeah, and then I wrote like, yeah. So it turns from 14.
That's it. That's it. Yeah.
It's plus 1 deviation. Plus 1.
Because it normalizes the standard deviation. And we just got 3 when we do it? Yeah, because we just got 3. Yeah. 16 minus 10, 6. Yeah, 3.
Yeah.
That's it.
Yeah, so like we're still kind of going.
So, yeah. Make
You put 10 and put 3 to the right, you get 16. That makes sense.
Make sure that
So like, you don't have to type so when you move 3 to the right, it's plus 3. Yes, 1, 2, 3, 6.
Yeah, it might be that. And it might be sensitive. It's like so. Oh, yeah. Yeah, that's it. That's totally it. We're copying that idea, but you're using that data. So you get a sense of it is. That's it. Also, probably if you have 10, we're gonna do that, and then we're gonna do the other stuff. Oh, steps. Yeah, this, yeah, that's part of it. And then we're gonna I'm gonna have you guys do this, and then that. And this. Yeah, absolutely. Everybody good? Or so? We're gonna do the next one. Second, or if you already started to work. Okay. So what we're gonna do is we're gonna work on the next one in just a moment, and then you'll create your own. And then we'll walk through it as a class so that it makes sense to you. So it'll be a little bit of autonomy in just a second. There's a very interesting study done where they had kids shoot basketball free throws from 3 and 6 feet. That was group 1. Then another group, 4 and 7 feet. We tested 2 weeks later how they would do on free throws. Now the test group was 3 and 6 feet. But there were 2 groups. So this group was also tested at 3 and 6 feet. Who do you think scored more free throws? The group that practiced 3 and 6 feet and I got tested with the same thing, or the group that practiced at 4 and 7? 4 and 7. Because, and we'll jump back into that in a second, because the variance and the disruption of learning made them learn better, which is why online or hybrid or modality of learning doesn't matter, because it's actually more of a challenge to actually learn better. So the next thing we're going to do is this. Now, assuming these are amazing basketball players, calculate X is 20 feet in your Z transformation and show your work, draw it, and then create your own. I'll give you like 5 to 10, 10 to 15 to do those 2 things on your own. I'll come around if you get stuck, and then we'll talk about it before we do the next step in the worksheet. Does that make sense, everybody? So like you literally can scroll back up and look at the steps in example 1 to work through it for those on your own. Just example 1, X equals 20, and then come up with your own X value and walk through that. So basically doing this twice on your own, ask questions if you get stuck, doesn't make sense, and we'll walk through it in several minutes as a group. Yeah. The Z-score. So X minus M, and then make your own X value. And also draw that curve. So we're gonna draw this at the end between your, like the standard and then the one with the Z-score for your X equals 20 and the one you all create. Yeah. So just like 2 problems, and then we'll walk through it to make sure it's making sense to everybody. Because usually that makes learning work. A little bit of a puzzle, and the brain connects it.
our dream says it, our other class, kids take tests in the class, like they're really like disruptive, they actually have separate. Yeah.
Yeah, they took, they put them in room A, and they're like, study this material, go have lunch. And then they have to go to group, and it's same room, so then when they test them in the afternoon, first group in the same room, second group in a different room.
Yeah.
Crazy, but it does put out this science, like online, hybrid, face-to-face, more disruptive it is, and it's anecdotal, but like a friend of mine, a couple years back, he was taking a really hard math, I don't even know if it was stats, it might have been like health, it might have been like something like more involved, and he had like a couple hours to take it, and he got into an argument with his wife for like, during that time, his kids were running around and misbehaving, he was managing all that while they got tested. Now it's anecdotal, that's not as scientific as like talk about where they did them, but there is something to like disruption and having it make sense. Because the brain's constantly trying to figure it out. That's what, like, if you're ever walking and it's obscure outside or dark or like the light's not perfect and you're like, oh, is that a person? And like, oh, it's a fire hydrant. Because your brain has all this previous data about that shape looking like a person. So your brain's like trying to just kind of give you the information, and then you look, you know, like, oh, it's a fire hydrant. But it's pretty, it's just like, I think it's really amazing. That's like transduction is really like the magic of psychology. Just like if we continue to immerse ourselves in it with the statistics, it should start to stick.
Yeah.
Versus if I was just like, hey, do it all on your own.
Yeah.
We do something together, we do something, and then your brain's like, oh, okay, this makes sense. Yeah, that's pretty amazing. So where's the power? It's in this class.
I should have been here.
So they did a study. They had two groups of people, they put their hands in ice cold water. And one of them was water first, was power. Social restrictions, yeah. So you actually get 5% stronger, which I'm not advocating talking like a sailor, okay? But you do actually, because of social restriction causes strength. It's crazy. So the next time, I mean, I don't know if you know, if you're doing some like counting nails or putting stuff together, which you totally can because everybody can do anything. There's no need for gender roles. But if you're like, and you go like, and like suddenly, you just said, first you got stronger. It's like if you don't. Then draw it. Own X. So draw like the.
That's all we need to get your son. Now when you
Draw X 20, then create your own.
So if you do like 10, 12,
And
20,
then draw that.
1, 2, 3 to the right is 16. So that would be your line.
Oh. I said create your own.
So you replace these
So
numbers with
I said you can use it,
numbers.
you can frame with examples of like basketball players.
So, right, so
Fine.
positive,
Or if you want to
so then you would.
say, or if you want to be more creative, just frame the scenario.
Picture is
And it's
just,
really easy. You just say,
that's what your,
this is the belt to run this.
problem
Our,
shows, and then.
our mean was this. Now, I'm setting this thing.
Well, the Z-score is free, but you're moving through
The practical application is how more Z-score. Something that's more like practicing the formula.
Oh.
The really helpful for you all foundational. So we get into like nitty gritty. Check that
In the
out.
book, like, in the example, in the book, it showed one standard deviation for 14, and then you replace all those numbers. Yeah, so now it's zeros in place of 10,
Zeros.
and then you're going to the right frame, and then 3 is where you're fine.
So whatever it is, it's gonna be technically, plus or minus to the Yeah, because, well, it's whatever mean I give you. So I gave you the mean in the first one. So for the next one, you either take the same mean or bring your own. So number two would be the same mean, so that'd be 10. Standard deviation would still be 2, and then x would be 20. So you multiply that. X minus 20 minus 10 divided by 2 is 30. Yeah, that's right. That'd be 5. So then that would be 5 standard deviations. Like that. Yeah. For each one of these. Just so you know the formula. It doesn't, like, we're not even drawing from this state. We're just like calculate a z-score. We're gonna go into depth on like actually scenarios where you can like grab meaning right now. We're just descriptive. We're gonna do the inferential short. Yeah, you can make up your own numbers. I would recommend lower numbers rather than higher numbers, which can math easier. But if you want to make it about basketball players, if you want to frame it up based on what I already gave you, that's fine. Or you can just say something totally different. Say people that learn online or on ground, there was the mean was this, the standard deviation was this, assuming there was a value of the, or just basketball players. That's yeah. Basketball players, or football, or whatever, or it could be a field goal, or soccer, like whatever sport you like. My favorite is hockey.
So if I'm like creating my own scenario, I want to talk about like how many home runs. So should I say distance or how many home runs?
Okay, so you would say something like, so what we could do is let me pull this up for you. What you could do is you could say, a researcher measures the farthest distance for home runs, that would be okay, in feet that it was maybe batted out of the park or batted out of the outfield or something like that. And farthest distance, or it could be home runs.
Of each player, would that make sense? Or would that just be like?
Yeah, or of the players. The data was normally distributed, so I would say the data is normally distributed, so we're gonna assume a bell curve. And then your mean or your average is how far they went. And the standard deviation is sort of the clustering, plus or minus to the left or right of the standard deviation. You can make it up. I would just do small enough numbers that they're not, I mean, anything under 100 would probably be fine. Let's say 1,000 feet will still work. It's just bigger number. Yeah. Not on the new one, no. Oh, so X. So I'm saying, you're saying the one you don't create on your own, right? The one that you're doing right now. So X is equal to 20. So we're still gonna have we're still gonna use these right here. Yeah, but if we say X is 20, mean is 10, standard deviation is 2. X minus M standard deviation equals 20 minus 10 over 2 equals 10 by 2 equals 5. Z equals 5, not 3. So it's 5 standard deviation points from the mean. Does that make sense? And then draw that like that, an example, and then create your own with sports, with basketball, however you want to do it. Your own. The third one is your own mean value, your own standard deviation. You can make up a number. I recommend smaller. Don't copy. Come up with your own numbers, because then you're going to walk through the formula better. So like, just don't make your mean 10 or your X 20 or your standard, like, to change that.
Yeah.
Change those numbers a little bit. You can go up 1 or 2 if you want, or down 1 or 2. That's fine.
You're gonna provide emotional support back then? Giddy up. Great. Great.
Well, mine, I would have one, but the access code don't work.
We'll get it to work.
Who else am I?
Just email. Just email me, but email me the entire access code and make sure you don't copy a letter wrong.
I was just emailing you a picture.
Or email me a picture or something, and then I'll forward it to the Sage people, and then they'll fix it, and then you'll get access. And right now, everything's open till the 2nd. So as long as they respond quickly, you'd have until Saturday at midnight to get those caught up. For WebAssign.
Yeah, mine wasn't working either, so I called them, and then the lady on the phone went through and like unlocked the door.
So you might have to call them, but you can keep me in the loop. They're going to be the ones that are going to fix it. I can't fix the access code. Only the publisher can, but they're really good over there. Ask for Argiana or Nicole, if you want to name. Argiana, yeah.
What? For WebAssign, yeah.
I mean,
Because it was already been due, I just gave you guys more time. It's 1, 2, 3, and 4, and then I think the other one's 5 is I think through the 30th. I haven't assigned 6 yet because we're not really there yet. Yeah. Yeah, I can do that, Gustavo.
I'll do this one. Well, we did this one on the board. The second one, we just did that for them. But I can do it again if we need to. What's up? Yeah. X is 20, so we're figuring out the Z score, which is 5.
So then, so for this graph, it would just be
Plus 5 for 5 standard deviations. We're just yeah. And then what's coming up is we're going to go into greater than, less than, how we get there. Yeah.
Yeah. Oh, okay. All right, next one. Yeah, navigate. Everybody, okay. X is 20. This is marked. I would probably like something with like the meters, like roll on the meters. I would just draw the mean so that we can see the difference between the standard and 5 standard deviation points, and the mean should basically be like right in the center of the ball. Makes sense? Yeah, I post more. It's fine on that. When you have promotion, just to I would like maybe work your means. Just, yeah, just, yeah. Yeah, it doesn't, it's just be a value. It's probably easier to move around. If we did that, it's so there. But it's probably just simpler to deal with. It's like, no, that's right. Yeah, so just come with your own standard deviation, your own mean, your own, yeah. So your mean, yeah. And then plug in your X score against that. So kind of like the scenario, I think, depending on how everybody's doing it, and might jump in the next thing. Well, and or do time, but I think they did theirs, and check out these folks. How's it going over here? Okay. Yeah, that's fine. And in that case, we're talking about meetings. Okay.
If you need like 3 to 5, Alexa, I can do that before I jump into something. If you want it. Okay, you're good. Okay. Okay. All right. So some more stuff. I think everybody got to the end, right? Mostly, right? So the unit table or Z table is a probability distribution to explain your list of Z scores and the corresponding probabilities. Those are the proportions underneath the area, underneath the curve we're talking about. So the steps, transfer the raw score into a Z score. We did that. That's plugging it into the formula. Locate the corresponding proportion for the Z score in the unit normal table. So for example, if we say a sample of scores is normally distributed, M is equal to 10, standard deviation is equal to 2, what is the probability of creating a score greater than 14? Now we're getting into the inferential meaning behind it. So if you look at figure 6.6 in your textbook, that represents the proportion or the probability of obtaining a score greater than 14. So we apply the 2 steps to find the proportion associated with the shaded region. Step 1 is transform the Z score. So X is 14. Z equals 14 minus 10 divided by 2. Does that make sense where I got that from? There's the mean right here. Z minus X minus M divided by 2 standard deviation. Therefore, Z is equal to 2. And then you can see the formula on page 184, approximately in your textbook, or 6.6, a score equal to 14. And the distribution is illustrated in 6.6. Take a moment to draw that, but use this data. You can use 6.6 as a reference. So just like overlay it again with drawing it, but with the data that I'm showing you. And then we'll do step 2 as a class in a moment. And then I'll have you do your own, but we'll walk through it. So just, that should be, you know, you guys did that. So let's keep moving. Yeah, you guys did that. Yeah, that's right. So in this example, we're looking for the proportion of Z is equal to plus 2 towards the tail. Now, what the heck does that mean? Plus 2 towards the tail. What we're trying to figure out is if we plug it in, if it's greater than 14. So the possibility of getting the score greater than. So we're dealing with what we're calling a one-tailed test. Left tail, right tail, 2 tails, left and right, 1 tail, greater than, less than. So we're trying to see if we get basically that cutoff point or further. That's why we look at the Z table. So the probability, if you look it up, is, so look, go into Appendix C and find your Z score of 2. And then you'll notice a proportion toward the tail is listed in column C. You should have P equals 0.228 if you go into that Z table. So if we go into our Z table, which I believe is right here. So if you're in your textbook and you go in here, I'll just grab mine. This is a Z table. We're looking for a Z score of 2. So where's 2? Not yet. 2.10. 2 right here. This is our Z score. We're going over column 3.0228. That's where we're getting our probability from. C is the area between the mean and the Z. The area beyond, sorry, the area beyond the tail right here. So we're saying if our cutoff of 14 is right here, or greater towards the tail, we're going to go find 2, z-squared 2. And because we're looking at beyond, like towards the tail, it's that probability in column C. And that's where I'm getting that from. Does that make sense, everybody? Column C, z-score. So the probability is 0.0228 of obtaining a score greater than 14. Therefore, if you list it as a percentage, it would be 2.228%, because you move the decimal over 2 places. So now on your own, we're going to do these 2 things. We're going to say a sample of scores normally distributed with mean is 9 and standard deviation is 3. What is the probability of obtaining the score greater than 18? So go back, plug it into the Z transformation formula, and then look at your Z-score against column C, and that'll tell you your probability. And then you make up one on your own. Make sense, everybody? What we're doing? I'll give you like 10 to 15 to work on that in groups, and then we'll take another break. And I'll walk around and help you if you get stuck. Make sense? If I've totally confused you, just tell me, I'll come back. I see some eyes are glazing over, some people it's making sense. That's fine. I'm gonna help them, I'll help this group. You just do it, well, you're gonna want to show your work on the map. Like the Z-score calculation. Like scroll up, you see how I did that up there? You see the steps? So the one that I just gave you, just follow the steps, plugging that into the Z-score. Oh, no, right where it says it now. See where it's bold that says then do this, right in that white space. Does that make sense? Yeah, so we're going to the Z. So what I'm saying is right there, right where your cursor is, figure out the Z-score. Yes. Yeah, yeah, so that was the one that we just did. So scroll down. So we just did this one right here. Yep. And then scroll down a little more. So that's what we just did. So see the step 1 and the step 2, and this is in bold, now do the same to follow the formula. So I'm saying take that data and then use the steps above it to do that. So you want to show, I want to see the math right there. Did I answer your question? Okay, cool. My other question up here.
Oh, it's not.
Make sense? Yeah. So make sure so it's P, whatever is that column, and then the percentage. Yeah, okay. And then create your. So what we're going to do is take this right here, and then take this. Look at the steps above where you look at detail and everything. Hold the probability. So you're gonna walk through the maps, create your Z-score, go out to your Z-score table, grab the Z-score, put two balls over to the column for your probability. The P is equal to whatever is in the C column. That's it. Then come up with your own numbers. I'm not even asking you for a scenario. Just say a sample is, and don't give me the same ones, obviously. Create that Z-score. So we're just talking about like scores greater than that. And we're only grabbing one of them because it's one hit on the right. So we're just saying if we get to this point or higher, what is that probability? Well, because our Z-score normalizes the standard deviation, the Z-score to the C column tells us what the probability is, and if you want to write it as a decimal, you just move over 2s. Does that make sense? Or do you want to walk through it? So right here, this is, mean is 9, right? Standard deviation is 3. What is the probability of a score greater than 18? X is 18. 18 minus 9 divided by 3. 9 divided by 3, 3. Z is equal to 3. Look up your Z score. Go 2 columns to the right. That'll be your probability. I'll give you the score greater than 18 with that I gave you. And then you can think of like an exam or some scenario if you want, and you're basically going to say a sample scores is normally distributed. Mean, standard deviation, you can make them up. What's the possibility of getting a score greater than 20 or 30 or 25 or something like that? Calculate the Z-score again and then write the probabilities. That's it. So it sounds clear to me, but I do this every day. So I can explain it more. Okay, well, walk through a step or two, and then just raise your hand, and I'll tell you or help you check the work. So all we're doing is so going to chapter 6 the line meditation. Here you go. Click on student resources. Go on chapter 6. Scroll down. And so like ours is scroll to 100. So 5 years score. So that's probability of score data. So you just want to make sure you're looking at those. This score is probably
Gustavo, you should have, these should be your answers. So part 3, what is the first 5 on that other worksheet? And then 6 through 15 is the worksheet we just did. So as long, so
you're not looking at correctly in the tape. That's all it is. Just not looking at correctly. So you should have. So column B. So column B looks very backwards. Let's just start with column C. Go to the top. Zero. Okay, so A. Stay right there. That and that should match. It does. So we look at the Z-score of this. So for the first one, we're just looking at the B and the C, and we listed them. So what's number 2? 2 is. But what was the Z-score? I mean, so that's the point. Okay, you confident, which is fine. You look at the slide.
So this, so number 2, look it up as it's positive. So number 2, 1. And then if we go back to the Z-score, 1 was right here, 0.3413, 0.1587. So we were finding, so for the first 5, you find the z-score in column A, and then write the 2 numbers to the right. Because that's your area between the mean and the z, and your area in the z beyond the tail. So what we're writing is we're writing this right here, this value, and that value versus your z-score. And then for, I'll come over there and help in a second. And then for this one, you see the area under the curve. Locate the z-score so the probability towards the tail is. So our answers were these. So these were, so like number 6, 0.00. Is that right? Yeah, look at the skis. So in column B, you see the area from the z-score back towards the mean. So then you're looking at column B. So this one, that's 0. Your next one is right here, Privateera, 0.3413. Well, how do we get here? Well, it's column B, 0.3413. Column B, 0.3413. Right here, column B, 1. If we check the answer, 1. Does that make sense? So for these right here, find these values in column B of your Z table, and then go 1 over to column A where it's your z-score and write the z-score. What? So just like column A, yeah. And then for your other one, it should be, yeah, same thing. It's all column A. So the first one's column B, go back to Z. The next one's column C, go back to Z. So you're going to find, so first we did these. So we did the first set was find the z-score column A and then list B and C. The next one was find column B, list the z-score. The next one is find column C, list the z-score. So it's basically column A, list columns B and C, column B, list column A, column C, list column A for your z-score. So first you're saying the 2 things for probabilities for my z-score to the right are this. And then we're saying I'm going to find the probability my z-score is this. Make sense? I'll come over and help you right now.
You're taking this.
Yeah, that's right.
We're gonna take it.
15870 just over. Percentage, yeah, that's it. You guys can hear it now. Oh,
Yeah.
I'll be over there in a second.
So like, going off of like.
Yeah. And then you use your z-score to get that p-value, right? Perfect. Yeah, because you moved over. Well, I think it's 0.62. Because there's 2 zeros, so it wouldn't be 62%. It'd be 0.62%, just below 1. Just be careful in the decimals. But other than that, yeah, nailed it. And then, yeah, and then we're gonna do the next part in a second, and I probably walk you guys through. Oh, I did the math right. The mean is 9, so 3 divided by 9, 3 and whatever the probability was. This is 9 and 7. Or 13 or whatever you call it. Yeah, P is 0.0013, 13%. Yeah, as long as you're, yeah. 0.13%. Yeah. This area, yeah. It's because the shaded area what we're talking about is this or more or greater. When we start talking, we'll get into like less than or greater than the direction that's 2 tails. This one was 1 tail, so we're saying at the point or greater. And it's all, and And I remember looking it up years ago, it's always at the point or greater, so if it falls right smack there where that line is, then it's, in this section, if it falls inside it, then it's different. So as we get into some things like, we're getting into like confidence intervals, we're like, where does this happen? If it's on that line or north of it or left of it, so we're just saying greater than, because if it was on the line, it would actually make sense? Okay. So to the right, so X equals 18. So remember Z, so Z is equal to X minus M always. So your value minus your mean, which you have that. Z is equal to X, which is 18. The score. So Z is equal to X, which is 18, minus M, which is 9. Divided by 3, because 3 is your standard deviation. Yep. So your numerator first, that should be 9. Divided by 3, which is 3. So your Z score is 3. So and then we'll and find 3 of these. And then go 2 columns on this column. That's your area beyond. And that is telling you basically, you see that line under like shaded? Yeah. So we're saying greater than, technically right where it intersects is at, greater than is equal to the right of that. So we're just dealing with greater than, so we're just saying what's the probability, and this table is going to tell you. So the probability of points is the second one. Yeah, it's not the, yeah. So then, if you want to look at the percentage, 2, right? So I think the probability of 0.0013 or probability of 0.03%, wherever you want to list it. Yeah. So you just label it. So see right there, the area beyond the Z in the tail. See, that's like where I shaded that. That's what you're talking about. And then the only other thing I'm asking you all to do is come up with some of your phone numbers. And we're not even using scenarios. We're just having a score. So you just come up with different means, different standard deviation, different X, do the formula, and then find the probability of the thing happening. So you can say something like, you can frame it the way I did and say, a list of scores is this, standard deviation is this. I would use small numbers. Yeah, it's beyond, it's the mean plus the tail. It's that one on the right there. So that's what you're calculating. So then your own is just the steps, the snippets like a score, the probability. And then you know what you're looking for. As if you want to write your stuff out, that's fine. But what we don't want to do, and I'm not sure what guys, somebody, no work, they just need assignment. I don't know who it was, but it was definitely this. You just want to make sure you're showing your answers in your work. I'm not going to give you credit. I might let you resubmit it, gentlemen, so I want you to do well, but you have to show the work of the steps. I am reading every day. That's what the great model is. I'm not just going to check these something. There's something on the picture.
Yeah.
Now, when you were doing presentation at that site, and you all work together, I might, one of them is just like.
Yeah.
Thing. You might have this there. What's this? Pretty good. It's starting to make sense. It's just something. So it's always, C is always equal to the value, minus the mean, divided by the standard deviation. And then once we know is the score. If you scroll to the very top of the Z-score table, so like that intersection line over there, R. So we're saying greater than technically right on the paper. That's the probability because that part of the curve is above the C We're gonna walk through when we do that on Y right now. And I can explain it to you right now. I probably would. It's probably better to spend time in this kind of step so that it starts to So we're just saying greater than. Yeah. So we're just saying if it, so we're saying we have our middle average, and we're saying our standard deviation is like what happens, and then we're normalizing the new value into the standard deviation, which is and then we tell our standard deviation where it falls to the right of the median sphere or Z scores, but then we're saying we want a probability of that. We have on the right C column is a probability. So the probability of P is point like 0.228 for example. You move the decimal over 2 places or multiply by 100, now you can see this percentage. Now we have a 2 point. So we have a 2.28%. So there's some possibility of the scores being higher. I think it's 0.13%. Because it was point P was equal to 0.001. So the decimal and then two spaces over for yeah. And then the last thing I'm saying is go ahead and create randomly random small numbers are easier than that. Now I did totally reverse engineer that. I knew that it doesn't matter, you don't have to do that. I'm saying make it your own, find some Z score from your own numbers, and then go into your Z score. But you can literally like look at my example, change my example, and make sure to change every number that deviation means. And your X value, and then go to the math. I'm trying to really like simplify every step so that it's Oh, okay. In the back? Is this group still working? Or are you ready to learn something? Okay. Eric, did you want to do the steps? Are you ready to jump into something new and or? You have to submit this, but not yet. There's some more of the worksheet. Not today. If we get through it, I'll give you a least through tomorrow. At least. I usually, a lot of times I'll say, a week from whenever we do everything, it'll definitely give you time to see. I care more about the understanding of the deadline. Deadlines are so important, and there's some firm deadlines, and you cannot have all semester go over. You'll run out of time. You won't be able to get it. We're not there yet. We're doing more. Okay. Okay. All right. I think everybody's probably in a spot where we can jump into that. I just wanted to get a pulse check. So I think just for time's sake, I'm going to do the next step. You can do your own on your own and submit that. And you can start to feel confused. Just kind of walk around helping guys. How's everybody doing? Do we need a break, or do you want to do something and then a break? How are we doing on time? How you guys, do you want to do another thing with this, or do you need like a few minutes? You have to make up your own. Yeah. So the next thing that we would do, everybody's good, or do you need like water or bio, or we'll do a break soon? Good soon? Okay. All right. So the next thing is, all right, so just some FY, total area is 0.500 above the mean and 0.500 below the mean in the normal distribution. What the heck does that mean? Symmetrical curve, half of the values are below the mean, half are above the mean. That's what makes it bell-shaped. If they're not half above and below, it starts to be skewed, left or right. So 0.50% is here and 0.5 is here, or 50%. Make sense, everybody? So an example, a sales team likes to send funny jokes around the office to break up the monotony of making outbound calls, or perhaps maybe it's the memes. You saw the meme, didn't you? I hope you saw the meme, Valentine. You see the meme from Monday? Oh, well, we can't have that meme for Monday. Yeah. So I don't have to work for anybody, so it's me. I might say that to myself. So if you can work for yourself, I recommend it. It's better. It's harder, but it's better. And the earnings are better if you work for yourself. Sales team likes to send funny jokes around the office to break up the monotony of making outbound calls. The manager wants to know how mindful his or her employees are of staying on task with the jokes being sent around the office. The manager develops a survey to track how often employees are off task. She reports they spend an average of 6.4 plus or minus 2.4 minutes. Remember, this is always mean plus or minus standard deviation. So I just gave those to you. That was being glaringly obvious. Off task during the day, assuming the data are normally distributed, bell curve, what is the probability that employees in this study spent less than 8 minutes, not greater than, less than 8 minutes off task during the day? So the first step, we're going to take our X score to a Z score. We compute the Z transformation. In this example, X is equal to 8. I can zoom in there. Is that better? Can everybody see in the back? Or if you're squinting, say I'm squinting, I can zoom in, okay? Z transformation formula, what was that? It's on the other side, yeah. We're going to walk through it. We're going to walk through how we get there, but you're on the right track. So page 185, you want to see this, the formula. Z is equal to 8 minus 6.4. Does everyone know where we got the numerator? Divided by 2.4, does everyone know where we got the denominator from? Standard deviation. We get 0.67. So in the distribution example, time equal to 8 minutes is located 0.067 Z scores, just over half a standard deviation above the mean in a standard distribution. That's not the exact picture shown in the book, but you can draw that accounting for 8 minutes. So in this example, we're looking for proportion from Z, not form, from
from Z is 0.67 back to the mean. And then we're going to add 0.5 to get up to the mean, which is the total area below the mean. So we're going from our tail. Here's our mean. Here's our 0.67. And then we're adding the 0.5000 to get up to the means we're dealing with less than. Does that make sense conceptually, I hope? So we're going to add 0.500, which is the total proportion of the area below the mean. It's because half of the normal distribution in this case is less than. To look at the proportion, we look in column A and C1 and appendix C for Z score equal to 0.67. So if we go back to our Z table, 0.67, that's our Z right there. And P is equal to 0.2486. Now, where did I get that from? 0.2486. So this is where we use the area between the mean and the Z score because we're talking about less than. So we're talking about right here. The area, this is why we use column B. So it's less than area between the mean and the Z score. Does that make sense?
So for the other one, this score is
Above the mean. Yep. Yep. And then it gets real interesting and fancy where we talk about above and below the mean, but that's coming. Okay. So we get, so this time we're looking in column B, and we're gonna do the same with your own example because it's less than. So column B, so 0.67 Z score. Column B is 0.2486. We add 2.486 to the proportion below the mean, 0.5000, half, and we get 0.7486, or 74.86% that employees spent less than 8 minutes off task during the day. What does that mean inferentially for statistics? We're sending funny jokes around to break up the monotony of making outbound calls in the sales environment, and we're measuring that people are off task less than 8 minutes per day. Maybe the jokes or the memes are working, right? That's where we get that conclusion from. So now using the exact same formula and the steps, do it on your own, assuming they spent 10 minutes off task per day. So X is going to be 10. We're going to find our values. We're going to go up to the mean. We're going to do those steps on our own. I'll come around to help you. Then we'll create your own. And I'll give you like 10, 15, 20 minutes or so to work through it. And I'll come around and assist you. And or we can walk through it as a class after you do it on your own. Make sense, everybody? So if you're stuck, literally scroll back up with the information I gave and plug it in again, and then do each step right above one by one, and that should get you there. If it still doesn't make sense, that's okay. Raise your hand and ask, and I'll come around as you're working through. So I'll check on you guys in like 2 to 5 minutes or so with each group. So if you totally go out in left field, it's fine. We'll get you back to the stadium. Yeah. Do you like the analogies, everybody? Yeah. The goal is to get you guys back out of the park throughout the semester. That's the goal here. So that's because it's an area up to the mean, so we're dealing with less than. Because this is 0.500 and this is 0.500. Half up to the mean because of the bell curve is equal distribution. So we're dealing with less than, we need to go back towards the mean. So we're adding half of the bell curve to the probability to find out the overall probability because it's less than. So we're calculating the probability of the thing happening less, which is why it's below. No, because we have the Z formula. So Z is equal to X minus M over standard deviation. You plug it in, you get this, then you add that. That's fine. You can ask 10 more times. It's fine. It's no big deal at all. So go find 0.67. And you're looking for the column B.
Yes, always.
6, you're gonna add that
Oh.
to the 0.5000, that's the probability of your less than
No. Yeah.
6.0500. Because this is 1.
Oh.
This
okay.
whole thing
No.
is 1. It's fine. That's fine. You gotta talk through it. It's also 100% if we're dealing with percentages. It's half. It's fine. That's why we have 4 hours of class, so that it's clear. If I said read the book, you guys would probably snore. The most that books are not written so much.
Yeah, so you're always.
Makes sense. So first you're gonna start with what? X is 10. So first, so we're gonna plug this in and we're gonna do the steps. So first just find your z-score with X. So 10 minus 6.4 divided by 2. You are. I'm just showing you the first one so it makes sense. Three point six divided by 2.4. 2.5. So then go find your z-score 1.5. Now go to the column B. So we went back up to a half right there. So what's that probability? The mean's not 1.5. It's normalizing your distribution. Always make sure that passes. So that's the probability of the column is 0.4. Column B. Because we're dealing with less than. And then you're going to add that to the 0.5000 to the mean. So the probability is less than 3.5. Of that is the whole thing is 100% of the So you can have like 0.9332 or 93% chance that they're spending less than 10 minutes off task. It's lighting, but we're measuring the efficacy or the transfer for how effective something is based on the folks going around Team Lightning up the mode based on the standard deviation. So we're saying how much are they being less and less off task because the jokes are working, so it's like where right now my worksheet. So that would be the probability that they're off task less than 10 minutes. So it'd be 93.32% or P. And then I'm saying 0.9332 or the percentage, and then I'm saying on your own. No, I would, yeah, let's try the graph, so that you know what you're looking for. So the area is between where your z-score is. Where your z-score is up to the less than. So you're going to go like backwards to the less than. So what you would shade in is technically be where that value is up to where the mean is. it's less than 10 minutes, so it's gonna be to the left. Because it's on the left. Yeah, but 0 in the middle and look where it's -10, right, that's Z-score, and then you shade out to. That's what we're looking at. So basically, if you look at what's on a Lotus computer, if you were to basically like flip that, right now it's shaded here is like the yellow is on the right side of the moon, you're just shading on the left side. Yeah, just like do like that, but like inverse it. Does that make sense? I don't think you don't actually at all when you're drawing. What I mean is the area between the mean and so where's so mark just mark the mean on that one. Where's the mean is 6.4, right? So first thing for that is mean. Yeah. So technically your bell curve would actually be like above that. So like you want to shift that because it would, wouldn't be that far over. Like make it closer to the center. Does that make sense? Like you can just draw that bigger, that's fine. Yeah, something like that. And then that's what you're shading. Because that's what you're calculating that area. No, just the left side is up. It's up to the mean. It's greater than it's the 10. And then I'm saying invent your own version of that with your own numbers. Figure out your Z-score. Go find the probability and then write. It's actually similar. Yeah, so you can so just take the sales data and just change numbers. Oh. Right there.
Sure.
It'd be a new X. So yeah, don't wait. Well, it's just like how we did it. Right?
Oh, we did.
Yeah. So if you wanted to say, if you want to just change your X value, that would still work for you. If you want to change all of those, that probably is the way to do it. Yes. Because we're on the left side, it's less than it's on the left side. We're going. We're saying less than. If we were saying, yeah, yeah, absolutely. So this is our 6.4 mean, right? 6.4. And then this was our X equals 10. Or our Z score, which was 4.5? 1.5. 1.5. So we're shading in this. We're going from the Z score up to the mean. So you weren't wrong, but it's because it's less than. If I was saying 10 or greater, or if I was saying it's less than.
Yeah.
So it's just like it's inverse because we're talking to the left of the mean, not the right of the mean. So we're not going greater than. Does that make sense, please? No? Yes? So, what was it? But it's on the other side. 10 is greater. We're saying less than 10 minutes. So because it's less than, it's our left tail. Because it's less than, it's like basically like negative. You can write it. You can write -10. Yeah, that'd be okay because it's correct with the zero. The zero's with the mean. That's about right. Yeah, up to the mean. Yeah. It's on the left side. Yeah. It's from the point on the graph towards the mean, because that was.
So it's not.
No, the percentage is right. Possibility is still correct. But because z-scores are always positive, so is your probability. So what we're saying is there's a 99% probability that this thing happens because the jokes are affected. So possibility of the thing of it being 10 minutes or less. Because it's going towards zero. 10 minutes or less from when you approach zero, which would be right where your mean is. No, you would just take 10 minus the mean, divided by the standard deviation, and then you're going to add it to what's left up to get up to the mean. And then that is your probability once you've gone from the z-score to the p-value. So the p-value, you know, is 0.5, so it's half and half. And then you add it, and then we're saying the probability of it being 10 up to nothing is 93% because the jokes are affected and people are getting things broken up a little bit. Does that make sense? Do you all hear me? So the reason it's on the left side is it's 10 or less and it will approach zero, which is your mean. This is coming to less. If it was more than, it was at least 10 minutes. Right side is 10 or more, and we're saying 10 or less. Left side is the tail based on the mean. Because it would approach zero.
I don't know why it stopped at the mean, because 10 minutes or less is above.
But the means like are zero points. So if we're gonna do some more complicated ones where it's like, should we see if it would be on this side or that side? Then you're right, but when it's at least, we're just dealing with just like our left half of our bell curve. Because technically, if we normalize the standard deviation with the z-score, it's going to be zero. Z is going to be zero right at the mean. So 10 minutes or less, left side, and we have to get up to like the 0 point or the average, and that's why we would shade the left side of the probability. It would still be 93% because the z-score over the C column over to the B column, and then you add that to 0.5000. So when we're on the right side, we're using the C column, on the left side, we're using the B column to get up to the mean to account for.
So when
Just remember, standard deviation would be the left or right of the mean because they go out like this. Is this making sense? So the reason that I initiate the other side is 10 or less. So it's going to approach zero, which is our z-score normalization. And when it's greater than our we'll deal with stuff where we deal with both tails, but right now we're just saying this or less than zero, or like at least this or more, puts it apart. Assuming it's normal, it's quick. They give it this like Steve. Wait, we're not really touching that. No, I think we get the F score. We do it. I'll walk you through. Like zero it's just like I needed more history in my life about why someone ended that way. Yeah, we're not. Pulse check. Is this all making sense? Making sense in the back? Makes sense? Okay. How's everybody doing? Do you need a break or do you want to do some more stuff? How's everybody doing? Should we take 5 or 10? 5? So it's 11:35. We'll see you at 20 till take 5, bathroom break, water, etc. And then we'll walk through some Z-scores a little bit more.
He has to, yeah. I mean, not to be. But he has to, he's the one sitting in the home, so I'm like, okay.
Yep.
That's what we just did, like on our own.
Yeah, and then you're, oh, then this should be like in the middle. That's
Do you
right.
want us to make like this other graph, or can we just make it?
I would do the other one so you can, this is gonna be the same, it's just the z-score is 2.3. So it's like that example where you're just gonna put the same thing with your standard deviations, because that's ultimately what your z-score is. Does that make sense, or did I totally confuse you? Makes sense? Okay, cool. Oh. All right, you guys ready? So locating proportions below the mean. So in a standard normal distribution, z-score is above the mean or positive, right? Because that's like the 0 point. Z-score is below the mean or negative. That makes sense, right? Everybody? Because a normal distribution is symmetrical, probabilities associated with positive z-scores are the same for corresponding negative z-scores. Does that make sense? All right, so researchers are often interested in the depression areas in many different groups, which can be measured using the Beck Depression Inventory. Individuals who experience chronic pain are one such group for depression of interest to the researcher. Using database and reports of published research, suppose a group of veterans who experience a chronic pain score scored 24 plus or minus mean plus or minus standard deviation plus or minus 12 on the Beck Depression Inventory, where higher scores indicate more severe depression. According to the conventions, the score of 13 or less is regarded as a score in the minimal depression range. Assuming the data are normally distributed, again, bell curve, what is the probability that veterans who experience chronic pain scored in the minimal depression range 13 or less? So we take X to compute the Z transformation. Z minus 24, that's our mean, divided by 12, our standard deviation. Make sense so far? So this is 11 divided by 12.9, negative 0.92. But remember, a Z-score that's negative, we're going to look it up as positive. So we look up 0.92 in the Z table. So you look that up, we're looking up column C, because we're looking at portion below the mean, and we should have 0.1788. So the probability that the veteran will score the minimal depression range, a score of 13 or less on the BDI-2 scale, or 17.88%. So just one of them on your own. Now, assuming, just calculate the Z-score. Assuming the data is 26 plus or minus 11, mean plus or minus standard deviation, calculate the minimal depression range probability of veterans with a score of 15 or less, assuming it is 15. Use the same Z formula and calculations in the example above. Please show your own work and then your own scenario. So literally, look at step 1 and step 2. Do those steps with this data and then your own. So you can literally scroll back up and walk yourself through it and or ask me questions and then do your own, and then we'll do another example. Make sense, everybody? Yeah. Now we're using C because we're dealing with the score of 13 or less. Because first it was like at least. So we're talking about, there is an example on page 186 of what that looks like. in the text. So you can visually see that. And if that still doesn't feel clear, Katie, I'll come around and assist you. Because the difference was, this was it was less than, and this one is 13 or less. Okay, I see what you're saying. Because we added it. Yeah, I'm just trying to see how I can explain that to you. Just went up to the mean. Should have an example on page 186 that shows you what I'm talking about. I think that might answer that. If it doesn't, just hit me up. The only difference. Less than. Oh, the difference is a nuance. It's less than, or it's up, or it goes up to. That's why we added it. So if we're just saying less than, it's that probability. But if we're saying all the way up to that point, that's where we add. Because if you look, it's like slightly different. This up here was 8 minutes, spent less than 8 minutes, so we could approach the 0. And this is nuanced as 13 or less. So I'm trying to think of a better way to explain that to you so that makes more sense for you. Oh, okay, I can explain it. So it was at least the 10 up to probably that they scored right here less than. It's because we're trying to see that they scored just not up to that point. I feel like it's sounding clear to me, but it's not sounding clear to you. I'm trying to get that. Try to think of a way to make that clearer for you. If it's less than, it's C. If it's up, it's like slightly nuanced. If we look at this one, it was. Yeah. Because we're not going to go back up. Because we're not going to go back up to the mean. It's because it's different. So if we look at 24 plus or minus, because that's our mean, we're not going to go back up towards 24. We're saying 13 or less. That's why we're using C. Like we're not going back up to like the mean. We're going back up to the mean in the other examples. Does that help or not at all? We used B. Yeah, that's right. So, so if we look at area between the mean and the Z, or area beyond the Z and the tail, that's what we're doing. So the area beyond the Z and the tail is over here. B is up to the mean. So we're not going back up towards the mean because the mean is 24. We're going to the right. We're going this direction because it's less than. I don't know if that's feeling more. So if you look right here, this is your area between your mean and your Z. This is your area beyond. So when we're thinking about that and we're saying, okay, the 24 is the mean here, we're not, if we said something like, what is the possibility of scoring between 13 and 24? We had to go back towards the mean because we would go back up to it. But we're saying 13 or less, that's why we're to the left. For C. Probably for this one now. Does that start to feel clearer or still? Okay. And we can walk through this one as that's part of stats. I can't make that stop. It happens the first time for me. I use stats. Part of it. It's just math. It would technically be, it would be this, because it's less than, because we're not going back up towards the mean. We're not going towards 24. Because of the one we just did, we went towards the mean. That's how we set it up. Just you saying 13 or less. It would be that section, yeah. Because 15 less than. There's another question. If we set between, we set at least 13 up to 24, then we would go towards it. But we're not doing that. We're just saying less than 13. So we're saying the probability of it's at this point. Does that make sense? If you can say it in different words.
That's the first one.
Or I can say that. So we're not going up to, we're not saying at least 13 to 24.
Yeah.
So we're not going towards the mean. We're just saying here or less. That's why it's the right probability. I feel like that's pretty amazing. I'll come back. You can ask me all of you are available inside out this classification phase. I think when I went through on Saturday morning, since the class started, it was kind of 3 hours talking about that. Yeah. So I got you, just gotta tell me what it What I did, I looked at for this, I'm using stuff in the book, so I creative examples. There's a bit of an overlay on the chapters where if I like reference something or I'm drawing something and it says a figure, and you're going to look at that in the book, it's going to be like a line in the column.
So this figure 6.7.
Yeah.
Oh my god, I can do that? Okay.
Yes.
So I drew like my thing from this one.
Yeah.
Our picture that we had submitted was just a dark yellow.
Yes. Yeah. So for that, so I think this is the one before because I was up to the mean, if I remember right. It was past the mean, so it's these are 6.5,
Yeah.
6.5.
They look at C.
Time.
So
So that was, yes, that was, so then you took this score, you got a p-value, so that it was that, and then you added it back to it. So what's shaded right here is the half into the mean, and then the light shade is probability.
Okay. Because then you only wanted us to show you the 0.5 and not the full. Yeah, that's right.
Yeah, this is right.
This one.
That's that.
Like, the second, the first one, but then the other.
Well, so you have like the regular standard deviation and what's showing in the other conversion is the score. So there are two. We have the one where you mark, okay, here's a 6. One of the, yeah. So like, yeah.
So this, the key term is plus then. These is
Then they
done
go-
to the median.
Yeah.
So then does it even matter that the score?
This here, this one you're using the 0.5, the other one's the.
Yeah, so it was at least, so I'm talking about a range. If I'm just saying less than probably that. On normal mileage and harder than. Sometimes you have to. But by all means, I know you work a lot. Just go to Costco. Around, any of y'all, it was an hour, it was a couple hours, and whatever y'all need. Within probably hours like maybe like 8 or 9 at night, you're down to any of you guys need to know works your schedules. If you're like, I need to do the whiteboard, I'm out here. If you're like, I can't get to any page, I have virtual whiteboard, it's kind of okay for me to draw. But I can do that. You just gotta sleep on it, wake up tomorrow, makes sense, cool. If it doesn't, that's cool too, just tell me that between now and Monday, if it works with our schedules, I will split it on time off one month. Or separately, sometimes I might ask to record or not, but Saturday, I have to figure out when it works, because it's just like that stuff. But it's the one over, but just sleep on it. Read more examples. Are you doing it? You're not doing that? And it's keywords less than or at least. So the one before was at least, you want a week with a range. At least this or just revalue. And then when I said less than, it just said the point on the actual track, like on the. Just see that. Let's go back. So that's, so mean 0.9 is going to this table. No, your Z squared. Right? Yeah. So then you're gonna find 0.92 at X, which is also exponential. And then you're the C squared probability. No, see that. So then the next one, take the same one, we'll just do the C score and then find C. And then the third thing I say is, for your own numbers, find your C, correct probability. And the nuance is, let's add this at least, we're gonna add that 0.5. If it's less than, we're just looking at the probability column. That's why we reason, because there was like a range, it was at least 2. This is less than, so it's just where it is on the actual.
So now we're gonna do
Is that the? 15 minus. Okay.
Assuming, yes, X, yep, 15 minus 26, right?
Yeah,
26 divided by 11. And that's what we give you your z-squared. And then you're gonna look it up. So many emails.
It's not like the standard, but it's like, yeah.
I think you can. Like voting, like real voting, not like a. No, there's faculty governance, there's student governance, there's all these things. And when you say voting at the community college, it's unclear. If you're talking about like the governor, like the Republicans, yeah, generally a school, usually there's voting thing. By the way, the law is 2 hours long.
Yes.
By the way, the law that protects you from your voting rights in America, and they can't fire you, is you can come to work 2 hours late or leave 2 hours early on voting day, and they can't do it. Whatever voting day is, you're like, oh, I was supposed to be here before boss, but I'm leaving at 2 so I can go vote. The polls are usually open 8 to 8, but you're allowed, federally, you're allowed 2 hours of your regularly scheduled work time to go vote. Now, they're not going to check, but I would recommend honesty. Like, you're going to take 2 hours off. Don't just go keep it with your friends at the park, at the stadium. Like, I would actually go vote. Because if they check, if they won't, then you have to. But you can take up to 2 hours off, or just do it around your work schedule. Usually, it's. I don't know why we can't vote. Like they could make, I mean, like I understand like fraud, that could be a problem, which like I feel like they can verify yourself, they can get one code, they can ask you a bunch of stuff, like besides your social security, make sure it's you. I think it'd be awesome if we could go online, but the system started with paper, you can start with internet. But I think it'd be really cool if we could just have it be legit fingerprint, something to really make sure it's you, and you start on the internet, that's so neat. But that's not a thing yet. I don't know if they'll let me. I think it should be. As much as we all went online, there are people that were told you can't work at this job online. The pandemic hit, they were really like something like 67. I think like 67% of all jobs can be online. It's not 100%. So you can't be 100% online. You know. Yeah, because we just do electric. Yeah, that makes sense. And then you look at that column C for the probability. Yeah, once you have your C-squared. Because that's the kind of likelihood thing happening is you over 2 decimals. So remember Z-squared always that positive on the left and the right. So you look at the Z-squared table as your probability. That's in the decimals or the percentage of the
I just think
She got me all.
Make it more sense.
I get the book, but I don't know why we would put -10 at the bottom and only do when it's more than half.
Because it's 10 minutes or less.
Yes.
So it's 10 minutes or off task or less. It's at least 10 minutes. It's at least 10 minutes.
And then after,
It's at least 10 minutes. It's not greater than 10.
I know that's why I didn't go above here.
So it goes up to the mean, which is 0. Basically. And then the other one, we just look at the probability of just scoring less than.
So
The right.
to
So when we're on right now, we're looking up C. Everyone before we looked up B, we added it back to the B. We're still on the left side.
That's how I'm gonna associate it. I don't think too much into it. Yes.
Yes. Right, and you're gonna add it. Because it's like at least that or more, like, or at least that up to that mean point. Yeah. Does that make sense in your head? To make it more. The reason at least goes back to more because it can be, whether we're talking about it being at least or less, or don't want to be at least or more, it's when we're backwards again. If we're saying just where is it or less than, and there's no range, probability is right at that. It's that point after having. Because there's a, because it could be. Does that make sense? Yeah. Things like that. Or something. More. No, this one is less than. So less than is just C column, period. They were asking why. Is less.
Yeah, so this one's less than.
This one's less than.
The other one was
Yeah. At least 10 minutes. I don't know. So the reason is I'm saying there's a range.
Right, I'm getting it.
You have to go through the mean for at least. But when I say just less than, I'm saying where it's one. That's why it's. Oh, yeah, that's fine. Yes, because you did that. You did the at least that's represented in the range, so it's from here up to the mean. It's limited, and this one was less than, so it's just where does it fall? Did you have a hand up, or are you still trying to type? They have a hand up in a second. I gotta check on these guys. Are you sure? No, you don't know your desk now?
I don't know, like.
What do you know the question? Tell me whether it's in this class or outside of class. I will help. We're still gonna do, I have more examples coming. I just want to go through that each one.
No, I'm getting my own scenario. Oh.
Everybody's in a fairly good spot. Okay, so the spot. So the spot is like see that this is the line to the left of that. We're shading that spot. We're saying where does it fall, and we're saying less. We're saying where to fall on that tip. So it's just that bottom one left hand corner. If I was saying it, I'm just goes back up. I'm just saying this falls here. We're saying it's on the left side. Less. It's like the little like. It's like less than is just like where it falls, so at least B plus that. We're still on this one. I'm gonna show you guys something important, just trying to get a pulse check where you're at. Face to face, or you'll have them all at the same time. Live session or something. And we're in class. I'm saying that, like, it feels clear now. Just got a text on call me, you know, and or we're being class. But I got your back. You guys talk. And you have 10 questions for 5. Are we about ready to show you some more stuff? Is it clicking? Need a little more time? You ready? Yes.
So I have a kid last year that my meeting was 200, and then last week was 105, but then my probability this year was 16%. So I don't think it should be that low.
It's based on the Z-score.
Should I find if I'm looking at C, it's 0.0062. But that doesn't seem right if my meeting is really.
What are you trying to have? That's why. That's why. The scenario.
So what is the probability of hitting a 195 feet or less?
Yeah, that's really a possibility. That would be sense. 60% chance, but you're very close to the mean of the average. You're not really far away.
It's not 60%.
Show me your p-value.
Okay. Z score was 2.5. C area of
Like you save people's lives.
and then we're not adding 25.
You put or less, so you would. So you're saying like a range. You're saying here or all the way back up towards it, so that would be plus point, and that would make more sense. So that'd be 0.506. That'd be like 54%. That would make more sense. Does that make sense? If you add it up.
So I have to add it?
You didn't just say less than like on the graph. You said this or less. So now you're saying like a range. Does that make sense? Less than 195, then it would make sense. Less.
Yeah.
Okay, now I'm pretty sure. 95 minus 200, by the way. I don't think your standard deviation would be 2. I think just plug numbers in. It absolutely makes sense, but I think your standard deviation would be different if your mean was. So the reason it looks wonky is because you just kind of threw numbers at the dartboard. That's if we. I think if you something like my mean was 15, or my mean was 20 instead of 200, I think your numbers would make more sense to you just because they're such big numbers. That's all. Ready for memory one?
All right, so example 2, I think everybody's either on your own at this point. So let's walk through a little bit more. If you're feeling strongly, you need more time on something, raise your hand and I can certainly do that. But I feel like you've had a chance to walk through it a little bit. Let's walk through some more stuff. So memory, is a factor often studied in patients with trauma. They might have a stroke. Do you guys need more time in the back or you good? One type is a conostat. That includes a series of tests with higher raw score indicating more severe impairment. Use database and reports to publish research. Suppose a large sample of stroke patients scored 7.5 plus or minus 2.5, mean plus or minus standard deviation. Assuming the data are normally distributed, what is the possibility that a stroke patient in the sample scored 4.1 or higher? So 4.1 or higher. Again, we're representing the range number on the right side of that mean. So 4.1 minus 7.5, 2.5. So that's 3.4 divided by 2.5. Z-score is negative 1.36. And then we look at the positive Z-score. You all follow me so far? Makes sense? So it's equal, that's a typo, to is 1.36 Z-scores or standard deviation below the mean in a standard deviation. In this example, we're looking for the proportion from Z is equal to negative 1.36 to the mean. So then we'll add 0.5000 because we're saying, do they score this or higher on the metric? So look at the proportion, search in column A for 1.36. Remember the portion for a positive Z-score is a corresponding negative Z-score. The portion given in column B this time, because again, it's that range, is 0.4131. So we're going to add that back to the mean. And the probability is 0.9131. They scored 4.1 or higher on the conostat metric. Did that make sense? Did I go too fast? Should I walk through that? Okay. So let's start with where we get these numbers from. So we have our Z-score. We have them scoring a 4.1 or higher. So that's our X value. 4.1 or higher. Or higher. I'm talking about a range here. That's why we're going to want to add to the mean. Okay. So it's not just like this, like the point on the map, like throwing the dart at the graph. This is representing the range. So they scored 4.1 or higher. So where does 7.5 come from? Well, they had a 7.5 plus or minus 2.5. That's our mean minus our standard deviation. So we're going to take 4.1 minus 7.5, X minus M, that's our mean, divided by 2.5, which is our standard deviation. So I'm taking Z is equal to X minus M over standard deviation. In this case, it's 4.1 minus 7.5 divided by 2.5. This is 3.4 divided by 2.5, which is negative 1.36. We find 1.36 Z-score, and we find column B because we're saying this or higher, so we're going to have to add it to the mean. So if we look at our table, where is that? That's right here, 1.36. Where is that? 1.36, 0.4131 right here, because that represents the area between the mean and the Z-score. So the Z-score does our standard deviation. It like normalizes it. I'm adding it to the mean because I'm saying the 4.1 or higher. So I have to account for the possibility to try to get closer to 1. So I'm saying or higher. So if it's or higher, it's on the right side of the mean. So it's going to be this plus the possibility. So 0.4131 plus, so your P is 0.4131, and that's your B column from your Z-score of 1.36. You add 0.5000 to it, you get 0.9131 probability of 4.1 or higher, or 91.31 or 91.3% or 91%. Yes. Sure. Yeah. So what does that look like on the graph? It looks like so 4 point, so here's our mean, right? and it's 4.1 or higher. So our standard our z-score was 1.3. It was 1.36. So it was 1.36. It doesn't matter. I think it was negative, but we're going to use that positive score, and we're going to add that to the mean. So this is the mean, or this is 0.5000. It's all of this, and it's that, because it's for higher. Sense, everybody? Not at all, a little bit. Makes sense? Because we have to do all of the mean up to that point without probability. So if we go back to our homework, so now using the same formula, you get this data. We're going to assume they had a 8.5 plus or minus 1.5. So that's always 8.5. So the first number is always your mean, plus or minus your standard deviation. So 8.5 plus or minus 1.5. Calculate the z-score, and we're looking for the 6.3 or higher. So we're going to add it back to that 0.500. We're going to use column B. Make sense, everybody? Do you want to walk through it as a class, or do you want to do it on your own? Okay. Sure. Yeah, I can. Yeah. Yes. Yeah. You're right. You're right. No, isn't it or higher? Or higher? Yeah. So or higher. Yeah. So it has to go all the way. Yeah. Or higher. This is the problem, like up to it, but we're also going above where it is on there. Does that make sense? Maybe? Not yet. Okay. So if we just said 4.5, what is the chance of them just scoring this, like 4.1? It would only be this. But because we're dealing with higher, that's why we shape both areas. Because it's more than. Because it could continue to go like technically like into infinity, like because it's higher. Yeah. Because we have to account for at least, because it said 4 point higher. So because we're talking about a range, we have to add the half of this to it. This is on the right side. I don't know if that's making sense to you or not. Let's do another one, and maybe it'll start to make sense. Suppose a sample of patients scored 8.5 plus or minus 1. Assuming these data are she was probably a stroke patient and the sample scored 6.3 or higher on the metric. So we're going to walk through. So step 1, we're going to transform the X score to a Z score. So I'm just going to move step 1 right here. Now, how do we do that? Well, let's take our Z scores and we'll do it on the whiteboard and then let's plug that in, okay? So it's not these Z scores. So the first one is X. So what is X? 6.3. So I'm going to change this to 6.3. And then what's our mean? Our mean is 8.5. So that's literally Z is equal to X minus M, standard deviation. Therefore, Z is equal to 6.3 minus 8.5. That's our numerator. Our denominator, standard deviation, is what? 1.5. So this is not right. We got to change that, 1.5. And then we'll delete that, and we'll delete that. Okay, so what is 6.3 minus 8.5? just for our numerator. Does anyone have that? So we're going to go negative 2.2, and then we're going to divide that by 1.5, right? Negative 1.46, is that what we get? You could technically do 1.5, or well, it's 1.6 repeating. So if it's 5 or higher, you round up. So we would probably do 1.5. And then we go into our z-score. So we have 1 point, and rounding's okay. You just don't want to, like, if you round the entire math problem, it might be a little bit off. If you round like towards the end, like when you have a z-score, then probably less of an issue. We're just dealing with 100. So 1.5, that's that 0.4332. I'd probably do 1.47. That's probably better because this is more accurate. Yeah. Just for a z-score, just so that our probability is more correct. Yeah. 1.47. I would probably do this rather than this. You could take the difference if you wanted to. If you want to be real accurate, I'd probably just go to the hundredths. So 0.492. So P is 0.492. So P is equal to 0.492. Is that right? Did I write that right? 0.4292. So 0.4292. So we just did that. And then we need to add that to the area above the mean. So we're going to do, so we could literally just take this and move this down here, but our answers are different. This is negative 1.42. So we're going to add 0.4232 to 4292. Yep. 92, 4292, 4292, 92, should be 0.9292, right? Yep. So it's 92.9% or 93%. And that, so the probability, so we literally just, you can move this right here. The probability is 0.9292 that this patient scored a 6.3, right? Or higher on the Conistat metric. And that's it. What? Graph. So that would be your this would be your 6.3, or this would be your 1.42. So it would be all of this and this, because we're higher, because it can keep going. That's why we shape both of those. Yeah. Negative 1.42 right here. Don't we have that? Did I mess that up? Did I write that wrong? 1.47. That was my bad. Sorry. 1.47. Yeah, 1.47. Then we got the probability. We added it back to the mean because it was that or greater, and our probability was the 0.9232. Yes.
So these graphs, just like because it wouldn't be 6.3.
Oh. Wait, what do you mean?
Like, so on 8.5 is the median, but then on the graphs we did, it was like it went from 1 to 3.
You would just adjust it for the data that you're looking at. So you're talking about like this down here. So
That's the question. So why is it 6
here after 8 and not before, that's what.
Normal X, Y.
Oh. Yeah, it's because it was technically on this side, and it was a negative 1.47 z-score. But we're saying if it's this or more, so we have to add it to the mean for it to be on the right side. So technically, so you're right, like technically, like your mean should be on the left, but we're saying this or greater, so we're looking at the side of the mean to the right. This is a positive number. 0 is kind of like that's your mean. What was that?
No, I'm just saying, that the mean is like the 0 and this side is positive and this
So
side
it's
is
negative.
greater than or less than. In that way, if you think it that way,
Because we found the difference this time, but it's still this z-score. All z-scores are positive, and we're saying that it's going to be this or more, which is on the right side. If we're talking about less, we would stay over here. And because when you do the subtraction on the numerator, you can end up with a negative number. But when we look at a z-score, we just look at the positive because it can go to the left or the right. In this case, it's going to be the right because it's greater than. That's why we're moving it over here. I feel like
so if the question was 6.3 or
less or lower.
it would still be on the right side?
No, it would be on the left side because it'd be lower. It would be less.
Okay.
It'd be
Even
on,
if the medium is 8 point what now?
that wouldn't matter because we're still talking less than the mean.
Just less and more. Don't think about the numbers. Forget about the numbers.
If it's less, left side, because the mean's like your 0 point. If it's more, right side.
Okay.
Make sense? Ish. Okay, so now we're going to do the hardest one. We'll do it as a class, locating proportion between two values. Assuming there was a study showing the possible benefits of playing video games between study sessions and academic performance, adults who play video games between studying for their statistics course tend to improve 18 plus or minus 10 points, because if you walk away from it, it might be more clear to you, right? So they tend to improve the second day they take the exam. This is just fake data that I made up. I'm not saying playing video games is going to help you, but it might. It might. Assuming the data are normally distributed, bell curve. What is the probability that a student who plays video games between study times will score between 12 and 13 points higher the second time he or she takes a statistics exam? So step one, so we have to calculate the z-score twice because we're talking about a range. So first we're going to take z is equal to 12 because that's x is 12 our value, minus 18 because that's our mean. So x minus m is this, divided by the standard deviation which is 10. That's where that came from. So z is equal to -0.06. And we're just going to write that down somewhere and we're going to come back to that. Does that make sense? You need more whiteboard stuff? I can do that. We're literally just doing this formula again. Z is equal to x minus m over the standard deviation. And it's 0.0. It's 0.6. Did I write that wrong? Okay, thanks for telling me the typo. Negative 0.6. That is z-score 1. We're just going to leave that alone and remember it for later. Because we're talking about a range. Z-score between 12 and 13 and 30 points higher by playing video games between stats, gen psych, child adolescent development, whatever you take my courses or any other courses, okay? Right? So we're going to find, so now that we have this, we're going to find 0.6 in column A of appendix C and look for column B for the proportion between the two scores. So we're going to add this to the second score because we're looking at the proportion between the scores. So we're just going to go and find column B, which is right here. So it was 0.6, right? 0.2257. So let's go back and let's put 0.22. Is it 0.2257? 0.2257 like that.
So we're going to add P is 0.2257 to the second score, X is 30. So then we already have that so far. That makes sense. Then we're going to say X for 30, 30 minus 18, X value minus the mean, divided by 10 is Z is equal to 1.2. So 0.2257. So we're going to go find our Z score 1.2. So our Z score is 1.2. Where are you? 0.3849. That's what I have, I think. Right. So we're going to add these together and we're going to get a different number. What is that? 0.6106. So the probability is 0.6106 that a student will score between 12 and 30 points higher the second time he or she takes a statistics exam, or technically, what, 61% if we were to move it over. Because we're talking about a range between values. So the range between values, figure out your Z score for the first value, find that in column B, write that down somewhere, leave it alone, find the second column in column B, and then you add the two together for a range of values. So the next thing I'm saying is calculate the probability between 14 and 32 points higher. Does this make sense so far before we do the last example? Yes. It would be the two different values on the X score. It might. Yeah, so it would be, so our mean was 18. So this would be like 18. So then we would have 12 over here, and we'd have 30 over here, and it'd be the difference between those two. It'd be a range, and then you would have your 0.6 and your 1.2, like your Z scores, because it would be between these values. The mean would be kind of in that range between the two. I think it was 1.2, wasn't it? The second Z score.
Oh, yeah.
So between 12 points left of the mean, because it's not 18, up to 30 points, and then I put the Z scores directly below this because that's normalizing the standard deviation. Make sense? So we need to, yeah, let's let you guys get caught up before you do the next example. Yes. So how about you work on the last one on your own, and in 5 or 10 minutes, we'll walk through the math and how you got there, and we'll call it a day. We'll do chapter 7 next Monday. But take a few minutes, work on the steps on your own. If you're really confused, we'll just do it as a class now, or take a few minutes, and then I'll walk you through it. Makes sense. Okay. We're going to use that. Remember, column B, value between values.
Yeah, so use the previous example, then just plug them in your numbers. Makes sense. The z-scores feel clearer? Okay, perfect. So you guys got the answer. You two ladies are still working, right? Okay. Be called because it's a portion between them. So we're gonna do both of them, like that example I have together. This your combined probability because it's between those two. And it's also like when you think about this, also like it stops. It starts and stops. Each one is part of the column. There's no need to be added. Does that make sense? I think I actually have an example. She has a free worksheet with more problems that I worked on. Yeah. The best that I might be able to do for you all is like after the class. I think I have a week or two, so I think I know what's testing. I know. You just took a test. I'm absolutely rooting for you to do well on it. That's why I'm practicing today.
Yeah.
We'll walk through this. We'll walk through this where everybody goes. I just want to make sure we're in a spot. They need another minute. Let's see if it's yeah. That's right. Yeah, that's.
Yeah. Space on 7 side. That's not my grade, but that's just how.
And then our last one. Is between me. Yep. And then it's actually right. No. So if we're just saying like his one of the map, C that we're saying is one of the map. It's between 2 points. This probability up to this one, and then the final ones, and just like shade there. For probability, it's B is like a range. Yeah, and then remember if there's going to be something that's like greater than, it's also a range. That's when we start adding feedback too, right? If we're just saying that just fall here like less than C, but we're saying at least or more, at least or. This is my last example. The one that you guys just did, yeah. Yeah. I'm gonna walk through it. Makes sense, John, or are you still working on it? So you go into your data, find your z value that you just calculated for each one of those, we go over the probability. For the B column, we're talking about a range between the two. Saying this possibility comes to this possibility. So there's no need to add it to the mean because we're just saying the range. We're not trying to get like this one or the left or right side. We're just saying so this and this. So you say this possibility.
This is a.
Whenever I put it to the other one. From the B column. It's the range. Which is like what I just did over that.
Okay, so.
Let's walk through it. Let's go ahead and walk through this last one. So the student will score between 14 and 32 points higher, right? So first we have to do, like, you could literally set it up like this right here, and then we'll just plug in the new numbers. So step one, it's not x equals 12, it's 14. 14, so 14, so it's still 14 minus 18, right? Because that's still our mean. Our standard deviation is still 10. So what's our first z-score? 0.4? Okay, so negative 0.4. I did that wrong. Negative 0.4. We can put a 0 or not. I'll take either. We'll put a 0 just to make it clean. What is the probability? What's column B? P equals 0.1554. Okay. Step two, we're going to take 32. So x is equal to 32. Oh, step. So we're going to add 0.1554 to the score for x is equal to 32. 32.
No, 14.
Yep, I got it right here. P is equal to 0.1554 for 14. And then we're going to add it, right? And this was 0. This was technically 0.4. So then the next step is for x is equal to, so we're going to grab this, and then that'll be the remainder of it. So step for x is equal to 32, a mean score. So 32. So 32 minus 18 divided by 10, right? So what's our other z-score? 1.4. So what is the mean score for 1.4 for the probability? Column B. 41992. So now we're going to take 0.1554 plus 0.4192. And what do we get? 0.5. Yep, that's right. 0.5746. The probability is 0.5746 that a student will score between 14 and 32 points higher the second time they take a statistics exam from playing video games. If we went 2 places over, that would be 57.46%. Does that make sense, everybody? That's the end of the worksheet. We'll do chapter 7 on Monday. I'm going to, so at this point, pre-test, post-test, chapter 6, and WebAssigns coming along with chapter 5. I've extended all WebAssigns through 5 up through Saturday. And I got you on the Tuesday thing, Gustavo. I just need maybe an email reminder where I can update that. What? So if you email me that, I'll forward that to them and they'll help you fix the code. Just make sure you don't put the wrong code in. Be very meticulous about it. Carlos, yeah. Yeah, chapter 6. But I'm going to give you probably till Sunday. I'm it's not due tonight. You just worry about taking the exam tonight by midnight. If you have any concerns about the exam or timelines on the exam, talk to me now after class, or concerns about the class in general, or questions. Other than that,
I'll see you guys in about 4 days.
When is the chapter 6 posted, you said?
I could give you till Friday if that'd be helpful.
Oh, it's whatever.
I was probably thinking today because we just did it, but we'll say Sunday by midnight. So yeah, because then you can work through 5 and 6, and then 7 will be new on Monday. I'll just say pre-test chapter 7 by Sunday at midnight. As long as you attempt it, you're gonna get all the points. If you do it by midnight over the weekend or maybe even Saturday, I can look at it and then think if there's anything specific I should review to teach you. But it's just an assessment of where you're at so that I can maybe cover something more. But you get all the points by taking it. If you don't take it, you don't get any points. Oh, Wednesday, guys. Wednesday, July 4th is a holiday. Also, we'll cover chapter 7 and or 8 on Wednesday. 7's easier. So I'll see you guys in a week because of the holiday. Yeah. Yeah. Have a barbecue. Enjoy some fireworks, something American. What? No, I don't. Monday's July 4th. I'll see you guys in a week. I'll post stuff in the announcements.
Okay, have a good weekend.
Yeah, you too. Happy 4th. Making sense? Or feeling clearer? Oh yeah. It's like what? It's like watching. Yes, and I recorded all that.